In this lecture, we focus attention on sizing the hot gas line and address issues pertaining to the hot gas line. During operation, the hot gas line carries hot, high pressure refrigerant vapor containing droplets of compressor oil from the compressor to the condenser. We need to be aware that high pressure drop due to undersized discharge lines reduces compressor capacity and increases compressor work. Conversely, oversized discharge lines may result in insufficient gas velocity to propel the compressor oil forward and then back to the compressor. Keeping these concerns in view, hot gas lines are sized for no more than around 2 degrees Fahrenheit pressure drop. In case the compressor is below the condenser, the inverted riser ensures that during an off cycle, the refrigerant liquid in the condenser does not slug the compressor. In the next few slides, we undertake the sizing of the hot gas line of a simple DX system example. Here again, we consider a 10-ton system using R22 as the refrigerant. The run length of the hot gas line is 40 feet and contains 2 elbows. We can quickly arrive at a suitable pipe size by referring to R22 piping guide shown on this slide. Suppose we assume the equivalent pipe length of the line to be around 50% more than the actual run length. That is 1.5 times 40 feet or 60 feet. 75 feet pipe length available on the chart is closest to the equivalent pipe length of 60 feet. Now, given the system capacity of 10 tons, we can pick off the suitable pipe size of 1 1/8 inch. To know the equivalent pipe length of the 2 elbows, we refer to ISHRAE data book table 4.2. Since the pipe size selected is 1 1/8 inch, the equivalent pipe length per elbow is 2.6 feet. The total equivalent length of the hot gas line works out to 45.2 feet. From the R22 chart shown on this slide, the pressure drop in the hot gas line is seen to be 9 psi per 100 feet of pipe. The pressure drop in the hot gas line for 45.2 feet equivalent length of the pipe will therefore be 9 times 45.2 divided by 100 or 4.06 psi. On this slide, we translate the 4.06 psi pressure drop to an equivalent saturation temperature drop of 1.2 degrees Fahrenheit, which is acceptable. This brings us to the end of chapter 3 of module 3. Thanks for watching.